Okay, good morning. This is the last topic in this chapter, equations of higher degree. It will take complete 2 lessons today and tomorrow, so then we will be finalizing this chapter and go back to the notion of inequality. So the topic is not directly related to the complex numbers, but this is brought in this chapter, so this is why I'm also considering this, and I will also connect it to the complex numbers a little bit because now you have the knowledge of complex numbers. So equations of higher degree makes sense if I have a polynomial. So when I say equations of higher degree, first of all, it means that I have a polynomial equals to 0. And here higher degree means degree higher than 2. No, because for 2 we also have a formula, ABC formula or PQ formula. For the first degree polynomials, we already know how to solve it, even from Grundschule. For the second degree, we have a formula. For the third degree, we have a formula. For the fourth degree, we have a formula, but the formulas are complicated. But Norwegian mathematician Abel actually proved that if the equation is degree 5 or higher, you cannot expect to have a formula to generate the roots of the equation. Okay, so it doesn't mean that we cannot solve any fifth degree equations. Yes, we can. Can you give me an example of a fifth degree equation that we can solve easily?
X to the power of 5 is equal to 50.
Is equal to 50 or whatever. Yes, x to the power of 5 minus 1 equals to 0. Yes, x to the power of 5 minus 1 equals to 0. If it is a math 1c problem, what the answer is? 1. But if it is math 4 problem, the answer is how many of them are there? 5. One of them is 1. The other 4 ones are complex numbers. And then I told you under the title of this equation. Do you remember? Okay, but anyway, you can solve it. It's a fifth degree equation, but you can solve it easily. I can, for example, have this fifth degree equation and I still can solve it easily. What is the degree of this equation? Again, 5. Can I solve it? Why we can solve it? How we can solve it? What? You have to factorize. So x to the power of 2, x to the power of 3 minus 1 is equal to 0. Either the first one is 0 or the second one is 0. But you can solve this and you can solve that. So you can solve the fifth degree equation here as well. But in general, if I write a full fifth degree equation, then you cannot expect that you can have a closed formula to give the roots. So it means that we have to use numerical analysis, numerical calculations to find the approximate values for the roots. But these numerical values is designed in a way that you can find the root at any degree accuracy that you desire. Okay? But here we don't want to talk about numerical analysis or things like that, so we want to see that if we can say something without invoking the methods of numerical analysis. So here, when I say higher degree for your course means degree above 2, which starts for 3 onwards. And usually you are dealing with 3 only in simple problems. Okay. Before cleaning this, we were able to solve this equation. It was a fifth degree equation. I was able to solve it. Why was it simple to solve? Yes?
Because we didn't have any terms with power.
So why this is beneficial?
Factorize.
We can factorize easily. So this is a fifth degree equation. The reason I was able to solve it more or less immediately is because factorization of this polynomial was trivial. Okay, just pulled it out and then use the zero product rule. But if I just add 1 to it, then you are in real trouble. Because, first of all, I want to remind you, this 0 plays a very vital role. Okay, so you cannot, some students say that, okay, still I can factor x2, I agree with you. First of all, this is not a factorization, is it? What is the meaning of factorized for? It should be written as a product. But if I ask you, for example, is this a product? What is this? Is this a product or not? No. What is this? It's a sum. sum between A, B, and C. So it's not a product. So I cannot say that this is factorized 4 because this part is product. No, the whole expression is the sum of two terms. So it is the sum, not the product. So it is not factorized 4. So this is not factorized 4 because this is like AB minus C. This is not also factorized. This is AB minus C equals to 0. So it's not factorized 4. So you might say, okay, why shouldn't I be able to solve it like this? I move 1 to the other side, then it becomes factorized. I agree with you. This is now factorized, but it is useless. Why? Because the product of two numbers is 1, I cannot say anything with. If the product of two numbers is 0, I can say something about A and B. Because I can say that either the first one is 0 or the second one is 0. But if the product is 1, I can not say anything at all. Because, for example, A can be 1, B can be 1. A can be 2, B can be 1/2. A can be 3, B can be 1/3. I don't know. A can be square root of 2, B can be 1 over square root of 2. So there are infinitely many options. So that is why we do not have the one product rule. We have the zero product rule. So that is important. I want you to understand, if you have forgotten these things, so that this is not factorization. If I move 1 to the other side, yes, I agree this is factorization, but this is one of the factorization which is not useful because the right hand side instead of 0 is 1. And if it is not 0, this method is not working. So what I need to be able to factorize so that the right hand side is exactly 0. Otherwise, even factorization is useless. And then factorization is not a trivial process. And that is the hard part of this problem. If I can immediately factorize all kinds of polynomials with having 0 on the right hand side, then of course I will use that method and solve all the problems. Okay? Okay. But let us try to, I want to motivate you by this example. So this is a third degree polynomial. The degree is just one level higher from your knowledge of second degree equations using ABC formula. But I want you to feel that factorizing this is not that trivial. The reason I can factorize it because before coming to school, I just engineered it myself, so I can do the reverse engineering more or less clearly. Okay? But of course, there are algorithms that can factorize this in a matter of seconds. But that algorithm is a repetitive algorithm. So for human brain is hard, but this is an algorithm, so you can just do that. Okay? So that is why if GeoGebra knows how to factorize this in a matter of seconds, it means that there is an algorithm that the GeoGebra is following. Okay? But that algorithm is not something that we can do especially if the degree is higher. Okay. So for example, if I want to factorize this, I want to do the factorization to see that how weird it could be. Okay, so for example, I can write 2x cubed. Instead of minus x squared, I write minus 2x squared plus x squared. Okay, and instead of minus 5x, I write minus 4x minus x. And then I write minus 2. It's very weird, yes? It is not illegal because minus 2x squared plus x squared is still minus x squared. And minus 4x minus x is still minus 5x. But why on earth I should think about this decomposition? In infinitely many ways I can decompose. For example, minus 5x can be written as minus 3x minus 2x. It can be viewed as positive 6x, negative 11x. Why I chose this one? As I told you, because before you come to the lesson, I did some calculations on the paper, okay? But now, can you see, if I tell you this, in principle, it is not hard anymore. If you have a little bit of experience. Now, can you see what is the benefit of writing these weird things here? How it will help me to factorize? Okay, let me tell you. This one and this one, take these two only. And pull x squared out. What happens? It becomes 2x plus 1. Okay, now can you proceed now? I want you to group them in a way that in each group, when you factor things out, this factor is left for you. Second one, and which one? X. And this one. Factor what out? X is not good.
Uh,
Minus x.
I'm
Yes.
sorry.
So this becomes 2x again. This becomes plus 1. So far, so good. You see, I have a new common factor. And then, of course, it is clear what to do next, yes? This one and that one, what can I do? I can take a minus 2 out. It becomes 2x plus 1 and is equal to 0. But that was good. Why? Because this strange thing to do helped me by this grouping to make a new common factor that I can pull out again. So I can take this and pull it out. So what happens? It becomes 2x plus 1. What is left from here is x squared. What is left from here is minus x. And what is left from there is minus 2 is equal to 0. Okay? And of course, this might be also possible to factorize more, but even if it is not possible, I am not in trouble anymore if my goal is to solve the equation. Because I would say that either this one is 0 or that one is 0. This one is 0 is a Grundschoolen problem, and this one is a Math 2C problem. You use ABC formula and solve it. Of course, in this case, you can factorize even more, yes? But let us say that I don't want to factorize anymore. At this step, I would say that because the product of two unknown numbers is equal to 0, there are only two possibilities, yes? Either the first factor is 0 or the second factor is 0. Okay, so the first factor equals to 0 gives me x equals to minus a half, so that is one solution. And then here I can, for example, use ABC formula, so it's 1 plus or minus the square root of 1 plus 8 divided by 2. So it becomes 1 plus or minus 3 divided by 2. Then I get two more answers. One of them is 2, the other one is minus 1. So in total, how many solutions I got? I got 2. So that's what I'm saying. You cannot expect be able to be creative so much. I told you, I have experience in factorizing this, but it takes me a long time. I didn't do it. Before you come to the lesson, I did something that I could immediately reverse engineer that. Okay, so that's it. So if you can factorize the polynomials, if you are very good in factorization, the lesson is finished. You just factorize and solve it, okay? But now there are some cases that we cannot factorize, but we can extract extra informations. That is the whole topic of today's lesson. So if I can get somehow an extra piece of information which is relevant, I can use that piece of information and factorize my polynomial in a systematic way, not very creative way. Okay? So how can I do that? For example, you might be able to accidentally guess a root. If you can do that, that is the lesson today. If you can guess a root, then this method works fine. But before telling you that, do you think, because I saw it in the book, there is a method to factorize this? Can you imagine there is another way to factorize this without guessing these kinds of hard things? It's good to know it. It's called the method of undetermined coefficients. To factorize. Forget about the name. Let us say that you cannot find this out, that you have to do very strange things like I did here to factorize. What do you think about another way to factorize? I give you this polynomial and I ask you factorize it, and you are not lucky enough to understand this method, to discover this, because to be honest, this is mainly by chance. Okay, any other way that you can approach the problem more systematically? Of course, it becomes longer in calculations, but doesn't matter in a systematic way. What do you think? In principle, you should be able to guess. You want to factorize. I have my gun in my hand, proverbial gun, and if you don't do anything, you will be dead. So what do you do? So goodbye then. You have to do something. It's very natural. I don't know why it doesn't come to your mind. No, think. You want to factorize. Factorize means writing the expression as a product. But the product of what type of polynomials? There are not a diversity of possibilities. The most natural problem is that, okay, what is the degree of my polynomial? 3. Let us say that this can be factorized. So what do you expect for the factorized form? Yes?
A lower degree, but like the combined, the factors should not add, it's at most the highest degree, or the degree minus 1, or whatever.
Yeah, you can imagine that this is degree 3, and you want to write this as a product of two other polynomials, because that is the meaning of factorization. So there are not that many options in front of you. Because you want to have the product, I cannot have this second degree and this is fifth degree, because then it becomes degree of 7. The degree is 3. So I can decompose it into a degree 1 multiplied by a degree 2. Or if I am lucky, as in this case, I can continue and write 3 degree 1 polynomials. Yes or no? Okay. So why we shouldn't bother to test one of them? So that's a systematic way, I'm telling you. So what I'm telling is that if you say this is factorizable, then what can I write? I can write it as at least the product of two polynomials, 1 degree 1, 1 degree 2. Yes? So what is the polynomial of degree 1? I don't know, so let me just write the most general case. Yes? And then I have another polynomial of degree 2. So let me use P and Q here. And for this one, I will have ax squared plus bx plus c. Yes? So that is the way that we do it. If this is possible to factorize this, then of course I should be able to write it as the product of two polynomials. But the degree of the product should be exactly 3. So one possible thing is that I multiply a degree 1 polynomial by a degree 2 polynomial. So in total, I have degree 3 polynomial. And this is the method of undetermined coefficients. It means that these coefficients I don't know. Undetermined coefficients. So I need to find out what these coefficients are. If I find P, Q, A, B, and C, then I am done. But of course, you already know P, Q, A, B, and C from my method. P is 2, Q is 1, A is 1, B is minus 1, C is minus 2. Okay? But now, there is a possibility to find them instead of guessing them. So how should I do that? Yes?
In the original expression.
No, in here. I want to find P, Q, A, B, C, and forget about this method.
No,
If you
no,
can
not
do
in-
that,
not
it's
in that method, but in the original expression, you can see the coefficient of, for example, x to the third has a coefficient of 2, and then you see that, okay, px and ax squared, so p and a has to be...
okay, systematically. We cannot, how many of these guesses you want to do? Systematically.
I know p and a has to have a product of 2. I mean, I don't know.
Okay, this is just solving about P and A. Systematically find all of them. Yes? So what should I do?
Not sure the entire way, but I would start by just like expanding.
Expanding. That's the systematic way. Systematic, don't be lazy. Yes? Sometimes you have to be lazy. Sometimes you have to do the brute force work. So this I have to expand. Yes? So what I do, I will multiply, so it becomes PAX cubed. And then it becomes PBX squared. Yes? Then it becomes PCX. Then it becomes AQX squared. Then it becomes BQX. Then it becomes CQ. Yes? But this is not organized because here I have one term, cubic term, one quadratic term, one term with degree 1, and one coefficient. So I have to organize it. How many places I see x cubed? Only one place. So I write PAx cubed. How many places I see x squared? Two places, this one and that one. So what happens? It becomes PB plus AQ. I factor x squared out. How many places I see x? Two places, here and there. I factor x out, so it becomes PC plus BQ times x. And then there is one term left for me without any x's, and that is CQ. Yes? Okay, now this is the polynomial after these two are multiplied. I want to fine-tune these undetermined coefficients in a way that the right polynomial matches with the left polynomial, not just for single value of x, for all possible values of x. This cannot happen unless the corresponding coefficients are exactly equal. So if I tell you make this equal to this, one possible way to think about, as actually Oscar said, this is only one of those equations you mentioned. So PA should be 2. Yes? And then PB plus AQ is what? Minus 1, because the coefficient of x squared is minus 1. And then I have PC plus BQ is what? Minus 5. And then CQ is minus 2. Okay, but I want you to feel this is a systematic approach, but not very promising all the time. Because how many unknowns you have here involved in this problem? I have 5. If P, Q, A, B, and C. And how many equations I have? Only 4. Okay? So it means that in principle 4 equation is not enough to find 5 unknowns. Okay? But you don't have to try hard. You should also count on your luck a little bit, an educated guess. For example, here, if I want, of course, the problem might be the case that P, Q, A, B, and C are fraction numbers, I don't know, strange numbers. But don't make their life harder for yourself. Try to start with some guesses that are plausible. I mean, natural numbers or integers. Okay? Because systematically, of course, you might be able to solve this problem systematically, but at least I hope that you understand this is not an easy task to do. Is it? I want to find a very non-standard system of equations. Okay? So, for example, let us see, we can have some choices. I mean, for example, let us say that by looking at this, I want to find some guesses. So let me say that I guess P to be 2 and A to be 1. Of course, you might say, why the other way around? Of course, I am cheating a little bit because I know the answer. But then you have to test the other way around as well. So, okay? So you test the other way around, it doesn't work, you come back to this. Okay, so if we assume that P is 2, A is 1, then I am relieved from this side, but I have to replace P with 2, A with 1 everywhere. So this becomes 2B plus Q is equal to minus 1. Then this becomes 2C plus BQ is equal to what? Minus 5. Then I also have CQ equals to minus 2. Okay? Then you start guessing C and Q a little bit. Okay? So you can guess again. So I want you to see that this method is not a very good method unless you don't have this factor of 2 in the beginning. Okay, because you see that I have problem. First of all, this problem should be hard because there are 5 unknowns, then I have only 4 equations. So I cannot determine all the coefficients directly without any guesses. Okay, this is a systematic approach, better than nothing, but it has its own hard things. This has its own obstacles in front of us. So because solving this system is not that easy. For some cases, solving the system is extremely simple, but for some cases, as you see here, it is not that simple. Okay? Now, this is why we want to start the lesson by extracting a piece of information from the beginning in my equation. Okay? Can you guess, without, of course, you know the roots, but could you guess an answer for this polynomial? If you are lucky and there is an integer solution to this, it is not hard to find that solution. Okay? Let me repeat. You have a polynomial equation with integer coefficients. And if you are lucky enough, which is always the case in your course, that you have an integer solution to this equation, my claim is that that integer solution is a divisor of the constant term. So let me make the claim clear again. If I have a polynomial with integer coefficients, okay, and if this polynomial is supposed to have an integer root, that integer root is among the factors of the constant term. Is that right? Okay. So, for example, if someone gives me this equation from scratch in national exam and they ask me to solve this, of course, if you are creative enough and solve it in that way, you are done. But otherwise, I focus on the constant term and I write all possible integer factors of -2. What are the integer factors of -2? So one of them is 1, the other one, 2, the other one, -1, the other one, -2. My claim is this. If this equation is supposed to have an integer root, that integer root is among these 4 numbers. Okay? First of all, I will come back to you. If you want, I will tell you why. Okay? Let me repeat. If I have a polynomial, okay, with integer coefficients, and if I am lucky that this polynomial has an integer root, that integer root is among the divisors of -2. Yes? So I wrote divisors of the factors of -2, all of them. One of them is the root of this equation, if of course this equation has an integer root. I didn't tell you why this is the case. If you want, we can discuss about why this should be true. But let us see how can I use it first. Okay, so let us say that in the national exam, they give you this equation to solve without anything, without any piece of information. The first thing you do, you go to the constant term, okay, and write all the integer factors of the constant term. They will not give you any question out of this row. Okay, and then you start testing them one by one. Okay, so for example, is 1 a solution? It is just, let us test it in our head. If I replace x with 1, this becomes 2 minus 1, 1, minus 5 is -6. No, it doesn't work. So 1 is crossed over. Okay, so what about 2? I put 2 there. What happens? Let me write it. It becomes 8, 16, and then it becomes -4, then it becomes -10, then it becomes -2. Oh, it worked. Yes? So now I am lucky. I don't need to care. Might be I can check the other ones, but it doesn't matter. I take this one. Yes? And now what I wanted you to learn is the method of long division rather than undetermined coefficient, which could be a mess. The method of long division is what I am trying to teach you right now. You take your polynomial, 2x cubed minus x squared minus 5x minus 2, and then divide it by x minus the number that you put in the box, -2. Okay? But this is not the symbol that we want to use. In American books, the symbol is different. I will follow the symbol in Swedish books. So the symbol is take this one and write it in this way. This is today's lesson. So I want to teach you how to do this division. Okay? I need a space, so if you don't mind, let me clean. So do you remember, if they give me this, I count on my luck and fortune. I go here and find all the integer divisors and try to test them one by one. As soon as I get one, I know what to do. I will take that polynomial, write x minus the number I got in the box, and I do the long division. How? In the way that I want to describe you now. What is the long division? First of all, you have to make sure that the powers are in descending order, from the highest to the lowest. If they are not organized, organize them first. And then what you need to do is one algorithm that I want to describe. And then when I say it's an algorithm, it means that you have to repeat it over and over again. So what you take the first term only. Let us go to a scratch paper. And the first term only here. And then divide them. It's extremely simple. So what's the answer? 2x squared. 2x squared is what you have to put on top here. And then you take what you got and multiply it here, not only by the first term, by every term. And then write them below here, but with opposite signs. So you take 2x squared, multiply it by x, it becomes 2x cubed, you write it here, but this is positive, you make it negative yourself. You take 2x squared, multiply it by minus 2, it becomes minus 4x squared. You have to write minus 4x squared here with the opposite sign. So you make it plus yourself. And then you start to add this blue one to the black one here. Okay? As if it is a Math 1C lesson. You have a polynomial, original one. You have the new blue one. You just add this polynomial to this polynomial. But one thing is clear, you have to still respect the order from the highest power to the lowest power. So when I add them, of course this is gone. 4x squared will be added to this one. It becomes what? 3x squared. And then these two, they don't have any similar terms, so I bring them down. I also respected the order. Power 2, power 1, power 0. If you learn this, that is the same thing over and over again. Let me just do it and then we can go. So what was the algorithm again? So you forget about what you have done so far. You concentrate on the first term and the first term again. So what happens? So you take the first term, 3x squared, divided by which term? X. What's the answer? 3x. 3x is positive 3x. I put positive 3x here, and I repeat the process. I multiply 3x not only by the first one, but by every term, and write them with the opposite sign below here. So 3x times x is 3x squared, but I change the sign, minus 3x squared. Okay, 3x times minus 2 is minus 6x, but don't forget, you have to change the sign. And then add them. When you add them, the first term gone. 6x minus 5x is what? Is x. And minus 2, I bring it down. Again, the same process. Okay? This process continues until two things happen. I will tell you here, but let us repeat it. Take the first term and the first term. You divide them. It's better to do these things in your head. So it is 1. 1 means plus 1. I multiply 1 here and there and change the sign. 1 times x is x, I change the sign. 1 times minus 2 is minus 2, I change the sign. And then I add them, it becomes 0. And this is the end of the process. Yes? This is one alternative that the process is ended. Okay? But in general, you continue this algorithm until either this is 0 or the degree of this polynomial is less than the degree of this polynomial. If that is the case, if I want to continue, then I will have fractions involved. Fractions are not polynomials, so we don't continue. So either, for your course, the majority of cases, this end up with a 0. But this is not always. For example, if I end up with 5, I stop. Why? Because the degree of 5 is 0. The degree of this polynomial is 1. Yes, if I want to continue, I have to write 5 over x. But 5 over x is no longer a polynomial. Okay? So, you stop here. But why this is useful? This is always the case, that your original polynomial is this polynomial multiplied by this blue on top plus what is left here. Okay? So, if I write this, so let me say that you start with polynomial px. This is your px. You divide it by, let us say, bx. Okay? And then you continue this. You get a polynomial on top. Let me call it qx. And then in general, when you continue, you get another polynomial here. I will call it rx. Extremely important that rx is 0 or degree of rx is strictly smaller than the degree of b of x. So you have to continue this process until either nothing is left or a polynomial whose degree is less than the degree of this polynomial is left. Whenever this happens, you stop the algorithm, and then it can be shown that this original polynomial is equal to this polynomial that you had in the beginning, multiplied by that polynomial that you found up there, plus the polynomial that you get here. Yes? Yes?
If it's not 0, then isn't this just useless?
No, I will tell you. Okay. So in general, this is the case. But now you tell me, what happens if Rx is 0? This is the only important thing I care. Because can I claim that P of x is factorized now? Is it a product? No, it is a sum. So I cannot claim P of x is factorized unless R of x is 0, then this is factorized. So that is why having the remainder 0 is important for me. If the remainder is not 0, this is still valid. But it is useless because that is not a product. And I told you, if it's not a product, I cannot use the zero product rule. And then it means that all the effort that I did is in vain, if the goal is to solve that equation. Yes?
So 2 factors is 2x squared.
Okay, I will write it now, yes. So then, this is always true. Remember, I want you to remember these facts. Okay, these are important ones. But in our case, P of x is my original polynomial. So 2x cubed minus x squared minus 5x minus 2 is equal to what? Is equal to this polynomial multiplied by this polynomial that I derived in this process. I didn't know about that before. 2x squared plus 3x plus 1 plus the remainder. But what is the remainder? 0. So we don't write. That's it. So this means that I succeeded to factorize this. So it is a combination of guesswork and a systematic work. But the guess is also systematic. I didn't blindly start guessing. I told you that in all the cases in your course, you will have integer solutions. And where should I look for the integer solutions? Among the divisors of this constant term. Yes? For example, if that is 16, you are in trouble because there are a lot of them, but you have to take them. Okay? Okay, but now let us finally solve this problem. So how should I solve the problem? I want to put this equal to 0 and solve it. But I realize instead of putting this equal to 0 and solve it, I can put this one, which is equal to this one, equal to 0 and solve it. So what happens? It becomes x minus 2 times 2x squared plus 3x plus 1 equals to 0. Either this one is 0, which gives me x equals to 2, Or this one is 0, but I don't have any problems with that because I have the ABC formula. So I use ABC formula. So what is that? X is equal to minus 3 plus or minus the square root of this over 2, 9, minus 8. 4 times this times that, divided by 2 times the first one, which is 4. And then 9 minus 8, 1, square root of 1, 1, minus 3 plus or minus 1 over 4. Then I get 2 more solutions. X is equal to what? Minus 4 divided by 4, minus 2 divided by 4, minus a half. So these are the solutions. So this, what I told you here on the board, I will give you an example that we can use the method of indeterminate coefficient. But I want you to understand, even though this was a reasonably good method, it is a systematic way, but the obstacle in front of me is a very non-standard system in front of me, so that I have to solve. It's not a standard system. You need to consider a lot of cases. But here, it might be lengthy, but it is an algorithm. You just close your eyes and follow the algorithm, the problem is solved.
So about that minus 2 there, did it come from the guess?
Yes, it came from my guess here. Yes?
So you could put in...
So you see, I wrote the constant terms, but I have to be optimistic and hopeful. Yes? Because might be there is a equation whose roots are 1 over 2, 1 over 3, and 1 over 4, for example. This method does not work for that. Okay? Because this method that I told you tells you how to find integer solutions, if there is an integer solution. It might be the case that the polynomial given to you has these roots, so that method is useless. But you don't face these kinds of problems in this Math 4 course. Is that clear? Yes or no? Okay. So if I want to review is this. If a polynomial of higher degree than 2 is given to you, and then you're supposed to solve it, there are two possibilities. Either they give you one solution to you directly, and then ask you find the other ones. In this case, you don't need to do this part. That part is done for you by the problem. If they don't give you that, then you have to use this method and hope for the best that the designer has designed the question in a way that you can use this method to solve it. Okay? And then, but what is the method? The method is that you start writing them down and start testing them. As soon as you find them, pick this one. Write your original polynomial, and here you write x minus what you found. And then do this method. It is guaranteed that the remainder becomes 0. Okay? Yes?
Is it always x minus what we found?
Yes. X minus what you found. But what can you understand that why it is guaranteed that this should be 0 if I follow that? Because when you say that 2 is a root, what does it mean? It means that p of x should be factorized so that when you put it equal to 0 and use the product rule, either this one is 0 or that one is 0. But you already know that 2 should be the answer. So this is definitely clear that x minus 2 should appear there. So this means that p of x is divisible by x minus 2. So the remainder should be 0. Okay? By the way, the name of this expression is called the divisor. Exactly like the people who had Math 5 with me, exactly the same names. Divisor. And this one, do you remember? It is called the dividend. What was this one in number theory? Quotient, yes. So that's the quotient. And this one, remainder. So here, the dividend, the divisor, the quotient, and the remainder. And this is extremely important to realize that the remainder, the degree of the remainder is smaller than the degree of the divisor. Or the remainder is 0. You know why I changed these two? Why I say the remainder is 0 or its degree is less than that? Because in principle, if I say degree is less than that, it should also cover this one. This is something I want you to know. If I say 2x, what is the degree of 2x? What is the degree? 1. If I say 2, what's the degree of 2? 0. Why? Because you can write it as 2x to power 0, for example. Okay? But if I ask you what is the degree of 0, what is the degree of 0? It is not 0, it is not defined. That's why people separate it. Why? Because 0 can be written as 0x to power 1. It can be written as 0x to power 0. It can be written as 0x to power 5, for example. So the reason that I say that the degree of 2 is 0, because I can write it as 2x to the power of 0, and then I say the degree is 0. But you see, 0 can be written in any one of these ways. So here, the degree is 1, here the degree is 0, here's the degree 5. So this is why mathematicians separate these two cases. They say either the remainder is 0 or the degree of r is less than the degree of this. That is a technical thing, but if you're happy with saying that all of them of degree 0, that's okay with me as well. Okay. Now, before moving any further, that is something that we will need tomorrow. So let us pave the way now. So, I want to tell you something. This process of long division might be very lengthy. So I want to tell you that in this case, I could solve it a little bit simpler. I want you to know about it at least. So let me clean what we don't need. Okay, something that I want to draw your attention to. So you see that this method that I told you here only detects the possible integer roots. So do you know, when we solve this problem, it is still on the board. One solution is -1/2. -1/2 is not in that list. So this method is not capable of detecting the non-integer solutions. Understandable? So you see, it is on the board. This is indeed a solution, but it is not in my list. Why? Because that is not an integer. Okay, but now let me tell you something else. Here, I started checking them out. I got 1. I was so happy that I jumped to the long division method immediately. But if you are patient a little bit and find all of them if possible. Okay, for example, let us say that I was not in a hurry. I put this in the box. I go further. Do you agree that -1 also works? Put -1 here. It becomes 0. Okay? So in principle, if you don't mind, let me put this one also in the box. This was good enough. I mean, if you write this in the exam, that's okay. My intention is to tell you something else. So let me put that one in the box as well. So now I know that 2 is in the box, so I have to divide by x minus 2. Or in other words, my polynomial is divisible by x minus 2. But on the other hand, because -1 is also in the box, what can I write? X minus -1 is that polynomial is also divisible by this, but the best way to write it is x plus 1. So you see, if I was not patient enough, I just found 1, I jumped to the long division, and it worked. Okay? But now let us say that I was more patient, and not only found this, but also found this. Because of that, I know my polynomial is divisible by this. Because of that, I know my polynomial is divisible by this. Okay? Can I say something more now? I know that my polynomial is divisible by both of them. So it is divisible by what? Let me ask your opinion. If a number is divisible by 2 and 3, what can you conclude? It's divisible by 6, but there is one caveat. So one thing that you have to be careful. If a number is divisible by 2 and 3, it is definitely divisible by 6. But if a number is divisible by 2 and divisible by 4, I cannot jump into the conclusion that the number is divisible by 8. For example, 4 itself. 4 is divisible by 2, and it is divisible by 4, but it is not divisible by the product. What is the difference between these two cases? Yes?
The first case, 2 and 3 are relatively prime.
Prime. So it means that the biggest common factor between them is 1. So here, these two polynomials are also relatively prime. It means that they cannot be factorized more. So now, because they are relatively prime, they don't have any common factors. If my polynomial is divisible by this and divisible by that, my polynomial will be divisible by the product. Yes? Yes or no? Okay. But what is the product? X squared minus 2x plus x minus x, and then minus 2. Yes? So instead of dividing your polynomial by this expression, you can divide your polynomial by that expression. It is more beneficial because the long division will be shorter. Okay? But this is not very long, so you might say that the effort doesn't worth it. But it's worth it. Let us do it later. Okay? So, but now let me just do the problem like this. I will take my polynomial 2x cubed minus x squared minus 5x minus 2, and I divide it by this polynomial, x squared minus x minus 2. Okay, so if you don't mind, let me clean this because I need to open that space there. I divide this by that. Okay, so what should I do? I will do something like this. Okay, this one divided by that one, what's the answer? 2x. And multiply 2x here, so it becomes 2x cubed with opposite sign. This becomes minus 2x squared, positive 2x squared. This becomes minus 4x, positive 4x. Then I add them. This is gone. This becomes x squared, and then minus x minus 2, and then we are done. One more step, yes? I put 1 here. When I put 1 here, the long division process is finished. So it becomes x squared with changing the sign, minus x, I change the sign, minus 2, I change the sign, so it becomes 0. Okay, so of course you spend a little bit more time here, but the payoff is to have a shorter long division. Sometimes it is crucial. I will tell you examples that you have to know this method. I will tell you why. But here I took the opportunity to teach you everything that is coming in one example. Yes? Any questions? Yes? Okay. So let me pause the recording and then clean the board, and then we start a fresh problem now, okay? Okay, now let me just write what we did. So for example, let us say that I have a p of x. I divide it by b of x, for example. Then I get a quotient up there. I continue. I get a remainder in general, r of x. Either r of x is 0, so I continue this process until rx is identically 0, or the degree of r of x is strictly less than the degree of b of x. And then p of x, the original polynomial, can be written as b of x multiplied by q of x plus r of x. This is something that you should have in mind, okay? Okay, before continuing, I want to tell you, why do you think that what I told you is correct? I told you that if there is an integer solution to your polynomial, if you want to find it, look among the factors of the constant term. Why do you think it should be the case? I want to convince you that the proof is the same I want to tell you here, but I don't want to write the rigorous proof. For example, let me write a polynomial here for you. Let me write a, z, for example, to the power of 5, plus b, z to the power of 3, plus cz minus, let me write plus a d, equals to 0. And let us assume that, this is extremely important, a, b, c, and d are all integers. Okay? I don't know why I wrote z. Let me write x. Okay. So all of them are integers. Now I am telling you that x naught is the root of this polynomial, and this is also an integer. X naught is a root and an integer. I claim that this root should be among the divisors of D. That was my claim. But can you tell me now why? Let me repeat. I told you that if you have a polynomial with integer coefficients and you have an integer solution for your equation, this integer solution is among the factors of the constant term. That was my claim. I claimed that at that point. I used this and I solved the problem. But why do you think this claim is true? Of course, I am giving you a very particular example, but you immediately realize that the reason can be actually generalized for all cases. So my question is that in the language of Math 5, I want to show that x naught divides D. Yes? So the people who doesn't have Math 5, don't worry. You just look at it like this. It means D is divisible by x naught. So why do you think it's the case? Yes, do you understand what I mean? This is the claim I did and I used. But now we want to understand it a little bit deeper. Why this is true? A, B, and C, and D are integers. X naught is the root and is an integer. The claim is x naught divides D. Yeah, exactly. As simple as that. So what you do, you put this there, so it becomes ax naught. Let me write it. When you say this is a root, it means it satisfies the equation. Let me write it and then wait for you. Okay, now can you tell me what should I do? It's, instead of, yes, you are right, divide by x naught. But instead of divide, what to do? Factor. Between these three, I factor x naught. Yes? So x naught comes out. It becomes ax to the power of 4 plus bx naught to power 2 plus c. And then I move d to the other side. So d becomes equal to the negative of this. Yes or no? So this becomes minus d, then I multiply by a minus. Yes, but that is done. Do you agree with me? Why? What type of number is this number? A, B, C, and D are integers. X naught is also an integer. So this combination is definitely an integer. Is that right? An integer with negative sign is multiplied by x naught and it gives me D. So this means D is divisible by x naught. Yes or no? Understandable? Okay. So that is important. So you see, these numbers being in Z is important because otherwise I cannot say this is a multiple of x naught. It is a multiple, but I want to have an integer multiple of x naught. X naught being in Z, A, B, C, and D being in Z guarantees that this combination is what? An integer. Okay, so that is the proof actually, but the proof for this case, but I hope that you agree that the proof can continue for all cases like this. Okay, that is also something I want you to learn, not to memorize. Okay, so now let us start solving the problems, some problems, okay? There is one important point. I don't think we can cover it today. We will cover it tomorrow. So let me see. This is the type of problem that you should expect. So example, solve the following equation. Yes? So the following equation is this: x to the power of 3 plus 3x to power 2 plus 3x plus 2. Even if you can factorize it, don't use that method, okay? If you are creative enough to be able to factorize it, don't use that method. I want you to learn this new method. So This is a question you should expect. How do you understand this is today's lesson? Because you are supposed to solve an equation with degree more than 2. So this means that this is today's lesson. Okay? Okay, can you tell me what to do? So let us review. If I want to solve this, I have to factorize it. Usually factorization is hard. So I need to ask myself, is there any way with a little bit of chance and luck, good luck, that I can extract an information from the problem? Okay, so the first thing comes to mind, according to what we told here, is you do what? You go to the constant term and start writing the integer divisors. What are they? Again, -1, -2, 1, and 2. And then you will start testing them one by one. But the positive ones need to be tested at all, because this is the bunch. This is the add of. This is the sum of some numbers. If 1 and 2 are positive, there is no way this comes back to 0. So why should I bother? Of course, you can test, but there is no hope for these two. Okay, so let us try to find another one if possible. Do you think -1 will work? Let us test. I put -1 there, so it becomes -1. This becomes +3. This becomes -3, and then +2. This doesn't work. Yes, it becomes 1, and it is not equal to 0. So this doesn't work. And this is the only chance that I have. If it doesn't work, let us leave the question. Okay? So I put -1 there. What happens? No, I put -1. Sorry. Did I? Yes, here I put -1. So -1 is gone. The chance is with -2. I put -2 there. It becomes -8. 4 times 3, 12. -6 plus 2. Yes, I hope this works. Yes, it works, yes? Because this becomes 14, -14. This is 0. That's correct. So the number I got is -2. So I put this -2 in the box. I know what to do now. What I'm supposed to do? I have to take my polynomial, divided by what? Tell me. No, not -2. Be careful. X minus the number you got. The number you got is itself minus. Okay? So you have to write x cubed plus 3x squared plus 3x plus 2, and you divide this by x minus that number. Minus -2. It's plus 2. Yes or no? Okay. And then this algorithm, I hope that you learned. So let me change my color here. So what is the algorithm? Only concentrate on the first term and the first. Yes, I don't know. Might be there are some questions that this is not organized. Be careful. You have to organize them first, from the highest power to the lowest power for both of them, and then start the algorithm. So this one divided by that is x squared, and then you multiply x squared there and write it with opposite sign here. So it becomes minus x cubed. The other one is 2x squared. I write it with negative sign here. And then these two are gone. This will be added here, so it becomes x squared. These are alone, so I bring them down. But I have to bring them down in order again. That's it. Repeat the process. So take x squared and then divide it by that. What's the answer? Positive x. Multiply that here. It becomes x squared. You change the sign. Multiply that here. It becomes 2x. You change the sign. And then add. So this becomes x. And then that becomes 2. It is not finished yet, because it is not 0, and the degree is not less than the degree. The degrees are equal, so we have to continue. So x divided by x is 1, positive 1. Multiply 1 here, change the sign. Multiply 1 there, change the sign. And then I am done. By the way, in these kinds of problems, definitely you end up with 0, because we guaranteed that that's the root. Okay, and then what do you do next? You write the factorized form of your polynomial. You say that x to the power of 3 plus 3x squared plus 3x plus 2 is what? Is equal to. What is that? I have to take this one, multiply it with the quotient, add the remainder to it, but the remainder is 0. Whenever the remainder is 0, I am able to write it in factorized form. So it becomes x plus 2 times x squared plus x plus 1. Yes? And now, in order to solve this equation, what can I do? I can say that this is equal to 0 because they are equal. And this is product, so it gives me two options. Either x plus 2 is 0, or x squared plus x plus 1 is equal to 0. Of course, this is not a surprise. I already knew that. Yes? Yes, this is just another confirmation. But this one you have to solve. But this doesn't have any problem. But now, because this is in the chapter of complex numbers, if there is a complex number, you should find it as well. In this case, yes. So what can I do? We use ABC formula. X becomes minus 1 plus or minus the square root of this 1 to power 2 minus 4 divided by 2. 1 minus 4 is minus 3. So it becomes minus 1 plus or minus the square root of minus 3 over 2. Technically speaking, this is correct, but you shouldn't leave it like this. You need to use the symbol of I. That is a have to, so you do it. So what happens? It becomes minus 1 plus or minus. Square root of minus 3 can be viewed as square root of minus 1 times square root of 3. But this is I. So this becomes square root of 3I divided by 2. If you insist to write it in a standard form, you just separate them. So minus 1 over 2 plus or minus a square root of 3 over 2I. So how many solutions are there? 3. One of them is real, 2 of them are complex. So this is the typical question you should expect. We can make it a little bit harder. We want to solve them. But this is the standard way. Sometimes they give you one solution. For example, they give you this equation and they tell you confirm that minus 2 is a solution and then find the other ones. Of course, in that case, that instead of guessing, you have this as a hint to use it and solve the problem as before. But let me ask your understanding a little bit. Let us say that I draw the graph of this function by GeoGebra. How many intersections with the x-axis you will expect? The first impression, it should be 3. But no. How many? 1. Because one of them is real. Yes? So when I draw the graph of this function, it means that I am working in the realm of real numbers. So when I am taking that coordinate system as the coordinate system of real numbers, it is not capable of showing me the complex roots. Okay? So if you draw the graph of this function will all intersect the x-axis at one number, and that's minus 2. So you cannot find the complex roots using this. One more thing that I will take the opportunity to tell you here is the fundamental theorem of algebra that was actually proved first by Gauss, called Friedrich Gauss, and that is telling you that if you have a third degree polynomial in the realm of if in the realm of real numbers, what you can say is that I have at most 3 real numbers as the root. I can have at most 3 real roots. But if you are working in the realm of complex numbers, then you can say that every third degree polynomial equation has exactly 3 roots in the realm of complex numbers. Okay? But there is one thing that you have to be careful, considering multiplicities. What do I mean? For example, if I give you x squared minus 2x plus 1, and I don't allow you to work in the complex numbers, if I ask you how many solutions are there for this? So this is a very simple equation. You write it x minus 1 to the power of 2 equals to 0. What answer you get? 1. Yes? But this root is, I don't know, have you heard about this or not before? This is not a single root. This is called a double root. Okay? And that is what I'm calling multiplicity. So even though if you ask me how many numbers I found there, I would say 1. But in principle, if I want to use the zero product rule here, I would say that this expression is the product of these two. So either the first one is 0 or the second one is 0, but both of them coincide. This is called a double root. Or you can say x1 is the root with multiplicity 2. Yes? So I want you to understand that fundamental theorem of algebra that I was, of course, fundamental theorem of algebra is a little bit weaker version, but the consequence of that theorem becomes this theorem that I tell you. So when I say that this equation in the realm of real numbers, what can I say? I can say that this equation of degree 3 has at most 3 roots. But in the realm of complex numbers, it has exactly 3 roots, counting multiplicities as well. Considering multiplicities. Yes? So for example, if you have a third degree polynomial and you solve it and you find 1 and 2 only in the complex numbers, you can conclude that one of them is a double root. Yes? Is that right? For example, in the complex numbers, you solve a polynomial equation and you get only one answer in the realm of complex numbers. What can you say about this solution? It has multiplicity 3. Because in the realm of complex numbers, if you have a third degree polynomial equation, it should have exactly 3 roots. Of course, you have to also count the multiplicities. Okay? So if I give you a third degree equation, and I ask you, I tell you that I solved it in the realm of complex numbers, there was one number I got, and that is 1, you understand that the multiplicity of 1 should be 3, because in total you should have exactly 3 roots. If you see 2 numbers, one of them should be repeated once, 2 times. If you have one number, that number should be repeated 3 times. Is that right or not? This is good to understand that. So in other words, if I give you if I give you a polynomial of degree 3, what are the possible factorizations of that in the realm of complex numbers? What type of factorizations you can expect about a third degree polynomial if you are allowed to work with complex numbers? One possible is I get x minus alpha, x minus beta, x minus gamma. If I have 3 roots, because this tells me that when I work, if this is a degree 3 polynomial and I am working in complex numbers, I have exactly 3 roots considering the multiplicities. One case is that I have 3 distinct roots. Then my factorization becomes something like this. But now let us use solve and you get 2 distinct roots. What will be the form of factorization? Can you tell me? So you solved a third degree equation, but instead of getting 3 numbers, alpha, beta, and gamma, you get only 2 numbers, alpha and beta. So what can I write for the factorization then? So for example, let us say alpha is repeated 2 times. Then you will get x minus alpha, and x minus beta. But x minus alpha, people write x minus alpha to the power of 2. This is another scenario. Or you might solve a third degree equation and you get one answer, alpha involved. Then what happens? What can you say about factorization? Yes? Minus alpha to power 3. But of course, if the leading term is has a coefficient, so you can also put a coefficient there. if the leading term coefficient, here the leading term coefficient is 1. But if the leading coefficient is another number, 2, 5, whatever, you have to put that leading coefficient here. Yes? So this is important. If you are allowed to work with complex numbers, every polynomial can be fully factorized with degree 1 polynomials. Yes? But if you want to limit yourself to the realm of real numbers, that is not guaranteed. But it is guaranteed it will be a product of first degree polynomials and second degree polynomials. Yes? So if you are working with the real numbers, then the factors involved is not guaranteed to be all of them first degree. Okay? But it is proven that it would be first degree or at most second degree. Yes? Okay. I just want you to know as extra information about these things that they are important as well. So it is very interesting. So if you have any polynomial of n degree n, you can factorize it to a product of first degree polynomials only. Okay, so I don't think there is one important part of this lesson is left, so I will actually do it next lesson tomorrow. So that tomorrow this lesson will be completely finalized. Any questions here? Okay, thank you.